everyone, welcome back to my channel Study with Amita. So today we're gonna solve the fourth problem of this TCS IPA coding series. So let's increase the level of difficulty. So this problem is a bit more difficult than the previous one, but it is quite easier. So first let's see. The first line of code is a number, and subsequently we are getting that number of integers value. So, and the expected output is like this. So let's see what actually the problem is. The problem is to check whether the given number is prime or not. Okay. So we are getting 4 integer value, and then we have to check it one by one whether the number is prime or not. If it is prime, then we have to add it to a list. If it is a non-prime, then we have to add it to a separate list. After that, we have to combine both the lists together and we have to print it as an output. So it is a very simple program, and let's check whether is there any exceptional case or not. So here there is no exceptional case, I guess so. So let me explain you all clearly what or how we can actually solve this problem. So the first line is we are getting that in case that number of integer we're gonna get the number of integer. That's the first line of input, and then we have to create a list. That is the input list. That is the input list, empty list. Let's create an empty list, and then we have to create a for loop. In the for loop, we have to get the input one by one. That means the number of input, and then we have to append them all of them into the input list. Okay. So this is the first stage, and then we have to create another for loop for in range of 0 comma n. Then we have to traverse to the list one by one. So by traversing we will get the elements, right? If it is 11, 5, 20 and all like that, first we have to take the first one. Then we have to check whether this number 11 is prime or not. So how we can check whether a number is prime or not? So first of all, let's understand what is prime number. A prime number is something which is divisible only by 1 and the number itself. So if 11 is a prime, then it will be divisible only by 1 and 11. So that is the example of a prime number. So how we can check this? So by using a for loop, we will get the first integer, and then we have to create a nested loop. So for j, so this will take the value from 1 to a number before 11. If it is like if the input list is L of I value, then it will check whether 11 is divisible by 1 and up to 11 is divisible by 10. So it will check like that. We know every number is divisible by itself and 1. So that's not a problem if we are checking 11 is divisible by 11 or not, because everyone know the number is divisible by itself. So the condition here is we want to check whether that 11 is divisible by 1, 2, 3, 4 and a number before 11. So up to 10. If it is divisible, we have to increase the count. We have to increase the count by 1. So we know, right? Now the case for prime is count is equal to 1. If count is equal to 1, then the number is a prime number. We have to add it to a new list. Else we have to add it to another list. So that is the exact condition. Hope you can understand. So we have to check one by one, and if it is divisible, we have to increase the count. If the count is equal to 1, we have to append the value to a prime list. Else we have to append the value to a non-prime list. So that is the case. So now let's write the program. Okay, in the first line we are getting the number of inputs. And then we have to create an input list. Let's name it as L. And then we have to create a prime number list. And then we have to create a non-prime list. Okay, totally we deals with 3 lists. Now we have to get the input, right? We have to get the input. For that, I'm creating a for loop. 0 comma n. I'm gonna let's name it as num. Num is equal to int input So I'm appending the value one by one to the list. Okay, now we got all the input and append it to the input list. Now we have to traverse the input list and we have to check whether the given number is prime or not. For that, I'm creating another for loop for I in range of 0, n. I'm gonna check whether the number is prime or not. For that, let's create a temporary variable. Let's name it as s. S is equal to L of I. Okay. So this is just for to make it simple. And then I'm creating another nested loop to divide it. Range of 1, yes. Okay. Now I have to check whether the yes is divisible by j. If yes is divisible by j, if the remainder is 0, then I have to increase the count by 1. Here I can initialize the count. Okay, this is the case. After that, if the count still equals to 0, if the count is equal to 1, then it is a prime number. We have to add the number to the prime. P dot append. We can append the value of yes. Yes, we have to append the number to the non-prime list, right? np dot append. Now we have to create a new list, right? We have to create a result list. Let's create an answer list. In that list, we're gonna append the prime list and non-prime list. So ans dot append. First, we are appending the prime list, and then we're gonna append the non-prime list. And at the end, we're gonna print the answer list. So this is the program. Let's copy the input case, and let's check whether it's working fine or not. Okay. Let's run the program. Okay, there comes some error. Okay. Let's run it again. Okay, we got the exact expected output. So this is how you can solve without using class method. It is very, very easy and you can pass all the test cases also. It is not that complicated. In case if you didn't pass any test case, then check for is there any exceptional case in the program, because they may give some exceptional case also. So check it and implement it. Like in a string, the exceptional case can be a case insensitiveness. So like that, some kind of case will be there. So do check it properly, and it is easy to implement. Hope it is helpful. See you all in the next video. If you like this video, click the like button and share it with your friends, and don't forget to subscribe to my channel. See you all in the next video. Bye bye.